Okay, this is, what is it, day 24? Okay, day 24. This is a confidence interval for a difference of two means, mu1 minus mu2. We are going to write hypotheses here just because it helps us write, if we're doing a test, and it actually helps us make a conclusion if we need to. So we've got a recent study in Pediatrics magazine. They investigated the effects of fast food consumption on other dietary variables. For a sample of 663 teens, we're going to call this N, who reported that they did not eat fast food, no fast food, during a typical day. The mean caloric intake, so the X bar for that, was 2,258 with a standard deviation of 1,519. And then it says for a sample of 413 teens who reported that they did eat fast food, yes, okay. On a typical day, the mean caloric intake was 2,637 with a standard deviation of 1,138. Construct and interpret a 99% confidence interval for the true difference in mean caloric intake for these two types of teens. So we are going to do a 99% two sample T interval for mu1 minus mu2. That's what we're doing. 99% two sample T interval for the difference in means. So our null hypothesis here is going to be that the mean difference, now we better come up with like abbreviations instead of mu1 minus mu2. But the null is always that the difference is 0. In other words, it doesn't matter whether you eat fast food or don't eat fast food, you eat the same number of calories, right? That's the null. Same number of calories no matter what you eat. And the alternative is that one would have more. So we need to decide what are we going to make for a subscript, a little label to tell us that this is not fast food. N. Okay, good. N means no fast food. So the N, and then what are we going to put for fast food? F? Okay. All right, and you can, when you're doing these, it doesn't matter what you put as your subscript. If you just use 1 and 2 and label them like that, I don't care. If whatever you can figure out for you to keep track of. So how do you want to subtract them? Does it matter? It really doesn't. You just have to interpret what it means the way you subtract them. So let's just do the mean difference. So the mean of no fast food minus the mean of fast food. Okay, so the null is that the difference is 0. But we want to know if it's different, okay, if it's the true difference. So our alternative, now in a confidence interval, the alternative hypothesis should technically always be not equal to, okay? So this would be that the mean difference is not equal to 0. Okay, that's the alternative for because a confidence interval is always two-sided because you're always allowing room above and below the mean difference. All right, so now we need to, we're going to skip the step 1, but at first glance, does it appear? Well, what is our sample mean difference? So the sample mean of not fast food minus the sample mean of fast food. So 2258 minus 2637. Gives me negative, whoa. I typed too fast. So it gives me that my difference is negative 379. So does it appear that there is a difference? Yeah. Okay, so it really does appear that there is a difference of negative 379, but that could be due to sampling variability. It could be due to a lot of reasons. Maybe kids underestimate or overestimate how much they eat. You don't know. There's a lot of reasons why we might be wrong. So we're going to do a 99% sample T, two sample T interval for the mean difference. Because it appears who eats more? Who do you think eats more? Fast food, okay? Since the fast food was second and the difference is negative, it means that people who eat fast food, here at least, tend to eat more calories. All right, so we would want to check our conditions. And when we check our conditions, the first one, is it a random sample? Does it say? Okay, so we are going to have to assume that the samples were taken at random. Okay, and now we do have three conditions here because it's not an experiment. So the next condition is the independence, and so we're gonna, let's see, 663 is less than 10% of teens who do not eat fast food. And we're going to have to assume that 413 is less than 10% of teens who do eat fast food. You have to look at each population separately. Each sample has to be separately. So it's like you're checking a set of conditions for each sample, but you can do it all at once. But you can't just combine all the kids, you know, both samples and say 1,076 is less than. You have to look at each separately. And then for the last one, n is greater than 30. So n1 is greater than 30 and n2 is also greater than 30. They're both greater than 30. So we can proceed. So now we're going to do our calculations. Our confidence interval is x bar of not fast food minus x bar of fast food, plus and minus our test statistic times the square root of the standard deviation of not fast food squared over n for not fast food, plus the standard deviation of fast food squared over n for fast food. So now we can plug in the values. We can use the conservative degrees of freedom, or we can use our calculator. So I'm going to go ahead and use I'll do both. So the conservative degrees of freedom, what's the conservative degrees of freedom? The smaller of n1 minus 1 or n 412. So degrees of freedom is going to be 412. So I'm going to have, let's see, don't I already know this difference? Didn't I already calculate that difference? What is it? Okay, negative 379. Plus and minus, I'm going to do my, well, I think I really like the t-table. That's a lot easier. So 99% confidence level. So 99% and my, let's see, 413, well, I'm just going to have to use 100 here, it looks like. So 99% with 100 is 2.626. No, yeah, 2.626. So 2.626, that's using, on my table, that's all I can use. The other option that I could use was I could go second distribution, inverse t, 0.995, and then with 412 degrees of freedom, and that should give me something probably a little more accurate, 2.588. So maybe I'll use that, 2.588. And then I can just plug in the numbers. So that would be 1519 squared over 663 plus 1138 squared over 413. So then if I do that calculation fast, that is ginormous. Okay, this should be right. Okay, so plus and minus 210.5. So the upper end of this interval is negative 168.5, and the lower end is negative 589.5. So that's by hand. That's a little, I mean, there's your distribution. My degrees of freedom was 412. Doing it on your calculator is, it's a little bit shorter. So stat, tests, I'm going to do a 2-sample T interval, and I've got the stats. So my first mean is 2258, standard deviation is 1519, and 663, and then 2637 is my other mean, other standard deviation, and N. Confidence level is 99, no pooled, and I'm going to calculate that. And it tells me if I use my calculator, I get that my interval is negative 588.9 to negative 169.1, and my degrees of freedom was 1038.16. So, are the intervals much different? No. What does this indicate for us? Is there a difference? Yes, there's definitely a difference. Why? Zero's not in the interval, the whole thing is negative, and we could even go on to say that it appears that maybe teens who eat fast food consume more calories, just based on these samples. So you've got a little bit of reading, and you've got 5 homework problems to do for next time. Right now, you'll need to just clear your desk of everything except your calculator. And if you'd bring your phones up here, that would be greatly appreciated. Yes?
May I borrow a calculator, please?
Yes, indeed. This one, I don't know if this is, yeah, if you can borrow that one.
Thank you.
Yeah, no problem. I'm still recording this.